Hello again, class. This is Chapter 8.3b in Math 7, finding the area of an irregular figure. Some books call these composite figures. If I look at my diagram here, it's actually a pentagon. We don't have formulas for pentagons. What we do have, though, is formulas for things such as triangles, parallelograms, rectangles, squares, etc. What we're going to do is when we look at our figure like this, we need to look for something that's familiar, things that have been combined to make this one. We look for rectangles, then we take base times height. We look for squares, we can use base times height. We look for triangles, we can use 1/2 base times height. We look for trapezoids, we just talked about that formula in lesson 8.3a, 1/2 the sum of the bases times the height. If we really look carefully, this particular figure is actually made up of two separate trapezoids. And if I switch over to a highlighter, I will highlight in blue that you have a left-hand trapezoid over here, and we have a right trapezoid, a right-hand trapezoid on this side. Nope, you don't have to highlight if you don't want to, but sometimes it comes in pretty handy. Now, it's easy to see that you really have two separate areas. The area that's in blue, the area that's in green. We will need to calculate both areas and then add them together to get the total area. I've recreated the drawing for page 2 here. You already have it, so we can get started here. Let's look at this left-hand trapezoid, which I highlighted in blue up above. I'm going to work with the formula 1/2 the sum of the bases, b sub 1 plus b sub 2 times h. Now I'm going to look at this trapezoid, and what I do is I ignore the smaller one over on the right and just look at the one on the left. Here is that right angle symbol that I always talk to you about looking for. That means that this is going to be a base, and if I follow this dash line up, this is going to be another base. So there's my b sub 1 and my b sub 2. This dash line is actually the height for the left-hand trapezoid. Now I can substitute into the formula. 1/2, my b sub 1 is 6, b sub 2 is 12, and my height is 8. If you'd like to hit pause and do the math, you certainly may. This one will have an area of 72 square centimeters. Now what I did was take 6 plus 12 is 18, divide by 2 is 9, and 9 times 8 is 72. I'm always looking for ways I can do it with mental math or easy paper pencil math to save time over using a calculator. Now if you remember on the diagram that I did first, I highlighted the right-hand trapezoid in green, so I'm going to switch to a green marker. Again, I have to write down my formula. That's pretty much a given for all of these problems, to make sure you write your formulas down. Now here, you've got to be careful. You have to ignore that left-hand trapezoid and look just at the right-hand trapezoid. You need to find the parallel segments. Here is this right, and here is this right angle. So for this one, this is my height. This 8 will be my b sub 1. The 4 will be the b sub 2. The 8.9, don't need, just like I don't need the 10. Well, what are they there for? We call them distractors, but they're actually there if you would do the perimeter of the figure, because we would just add up everything around the outside to get the perimeter. But they also are there to not just distract you, but to make you, to force you to really look at, hey, wait a minute, 8.9 can't be a base because it's not parallel. 10 can't be a base because it's not parallel. It can't be a height. Neither one of them can be a height because there's nothing perpendicular about them. So that's why they're there. Now I'm going to substitute. So my b1 I'm going to take as 8 because I work from left to right. b sub 2 is going to be 4, and my height here is going to be 8. Again, if you'd like to hit pause and do the math, please do so. Otherwise, here we go. It's 48 square centimeters. 8 plus 4 is 12. 12 divided by 2 is 6. 6 times 8 is 48. Now to get my total, I have to add these two together. Yes, you have to show this. Please use an addition sign because that's the proof of your explanation or your explanation. Somebody looking at this can say, oh, I know what this person did. They multiplied for the left, they multiplied to get the right. All right, then they added to get the total. And our total will be 120 centimeters squared. Let's look at example 2. Now here again, this one's a little complicated. If you look at it, you have a trapezoid over on the left, you have a rectangle smack in the center, and over on the right you have a triangle. Now I'm just going to work a different color for each section. I'm going to do the trapezoid in blue. Area equals 1/2 b sub 1 plus b sub 2 times h. Now here again, I've got to look for right angles. Well, here it is, and here's the other one. So that means this is actually my height. So this is going to be b sub 1, and this is going to be b sub 2. So my b sub 1 is 4, my b sub 2 is 9, and my height is going to be 4. When I do the math, my area is going to be 26 square centimeters. Then I am going to work with the rectangle in the center. Well, a rectangle is a parallelogram, so that's b times h. And the only two numbers I really have are 9 times 10. Doesn't really matter if I put 9 first or 10 first because of commutativity. So I will get 90 centimeters squared. Then I'm going to do the triangle. And that I'm going to do in red. Area of a triangle is 1/2 BH. Now this is why it's very important that you're familiar with the various formulas and why I have you work with those flashcards to learn the formulas. 1/2, the base, which in this case is 8, and the height, which is 9. Half of 8 is 4, 4 times 9 is 36 centimeters squared, and I have to add to get my total. I'm going to take 26, 90, 36. Yes, I'm going to use an addition sign so that for sure when someone sees that, they go, okay, they added, and you should get 152 centimeters squared. That concludes lesson 8.3 on finding the area of an irregular figure. Please respond with rectangles. Scouting out.